Hi everyone, in this video I'll be going through chapter 8 circles, the revision set B questions. So let's begin. Let's look at question 1, B1 from set B. Okay, a circle intersects x-axis at these 2 points here and intersects the y-axis at this point. Whenever I see such questions, I usually like to draw out the diagram to help me visualize the problem better. So over here, let's say I have, let's draw my axis out. Okay, imagine this is my axis. Based on this question, the question says that I have this circle. Let me let the axis be blue. Okay. I have this circle here. I draw the circle. This circle cuts the x-axis at 2 points and it cuts the y-axis at 1 point. So maybe it can look something like this, whereby your x-axis is a tangent, the y-axis is a tangent to the circle. So let's label the diagram clearly. This is my y-axis, this is my x-axis. I label the points here. I probably have point R, a point R. Okay, then over here, this point here, put across, this will be point P. I call this, let's say 13, and this point here, 27. Okay, it's not very proportionate, but this is point Q. Okay, so based on this diagram, and I try to understand the question says find the equation of the circle. So whenever you see equation of a circle, always remember, to find the equation of a circle, you need to find two things. You need to find, one, the radius, and the second thing is you need to find the center of the circle. So let's look at this diagram. If I were to look at this diagram, right, I can see that if this is a circle, and this circle cuts the x-axis at these 2 points over here, the center of the circle, let's mark it with a cross, somewhere here, okay? The center of the circle, the x-coordinate, must lie in the middle of 13 and 27. Okay, so over here, the center of the circle must lie in between point P and point Q. So very simply over here, we can find, first, x-coordinate of center of circle. Okay, this x-coordinate here is simply this distance, 13, plus this distance, the midway point between 13 and 27. So this is simply equals to 13 plus, then I take 27 minus 13 to find this distance here, then I divide by 2. Okay, so over here, I take 27 minus 13, the whole thing divided by 2. Okay, therefore, your answer should be 13 plus 7, which is equal to 20. So therefore, I know that, therefore, let's let the center of the circle, let the center of the circle, the coordinates be, I know the x coordinate now, 20. I don't know what's the y coordinate, so let's call it, let's say k. Okay, so over here I call this point 20, comma k. Okay, so now my next step, I want to find out what is the k over here. Based on the information given by the question, I need to find center and radius. Okay, and I know that from the center of the circle to any point to R, P, or Q, these are the radius of the circle. So therefore, if I were to just consider the distance between the center of the circle to any of these 2 points, the distance should be the same. So let's say I find the distance from center of circle. Let's label over here. Maybe I choose this distance. Let me label. I choose to find this distance here. I call this R1. Okay. Another distance I can use is, let's say I choose P. Okay, this distance here I call this R2, radius 2. Both of the distance are the same. So over here, since I know that they are both radius, R1 is equal to R2. Therefore, I can use the length formula. The length of R1, this length here, if I will take into account the coordinates of R, let me write out 0, 9. P is 13, 0. Okay. To find this distance here, okay, by the length formula, this will be square root. Apply square root. Okay, of, okay, x coordinate is 20. 20 minus minus R1 0 square then plus, next is the y coordinate, k minus 9 the whole thing square. Okay, this is my r1 distance. Okay, this is equal to r2, which is this distance here, which I can take the same thing, square root of 20 minus 13 the whole thing square plus k minus 0 the whole thing square. Okay, so from here, I simplify from here very easily. You should get 400 plus k minus 9 square equals to 7 square, which is 49 plus k square. Okay, what I do is that I square both sides so the square will disappear. Okay, by squaring both sides, then I simplify the numbers to get this. Okay, then from here, I continue to expand and simplify very simply. 400 plus k square minus 18k plus 81. This whole thing is equal to 49 plus k square. So therefore, by cancellation, I know that 18k should be equals to 432. And therefore, k is equal to 24. Okay, so by this equation here, I've solved for k. Therefore, center of circle is simply 20, 24. This is for the center of the circle. Then, now I've found the center of the circle. Next step is to find the radius. So radius is very simply, sub in the center of circle formula. Therefore, radius of circle is simply equals to square root of, by the distance formula, square root of 20 minus, let's take 1 point, let's say I take point P lah, okay? 20 minus 13 square plus 24 minus 0 square. Okay, therefore from here, the radius of the circle is simply, if you use a calculator to calculate, 49 plus 24 square, square root of this, press the calculator, you should get 25. Okay, therefore final answer, therefore equation of circle is simply x minus 20 the whole thing square plus y minus 24 the whole thing square equals to 25 square. Okay, and therefore simplify your answer over here. Answer is x minus 20 square plus y minus 24 square equals to 625. And this is for question 1. Okay, alright, so now I hope that's okay for you. Let's move on to question 2. B2. Okay, B2, this question here states that this circle here passes through the points A and B. So I've drawn out this diagram to help us visualize this question more clearly. Okay, point A here, we know that the coordinates is 0, -3. Point B is 2, -1. Oh, let me label that -1. Okay, so the question here says center of the circle. So I don't know where's center of circle. Let's label it somewhere here lah. Okay, passes through the line 2x plus y equals 0. If I were to rewrite the equation of this line, okay, for part 1, okay, y equals to -2x. Okay, so that means this line is a downward sloping line, a line that passes through the origin as well. So maybe the line looks something like this. Okay, is accurate? Something like this. Okay, let me put the line as red. Okay, so for this line here, this is the line, y equals to -2x. Okay, then our question says, therefore, find the equation of the perpendicular bisector of AB, meaning that AB here, I want to find the equation of the perpendicular bisector. And in this case here, the perpendicular bisector of AB will definitely cut through the center of the circle. Okay, but we cannot assume that the center of the circle, this perpendicular bisector, the equation is the same as this line here. So what we need to do is that we can use 2 different methods. Let's label them. I call this method 1. Okay, method 1. Method 1 is the one that everyone should know. How do we calculate perpendicular bisector? Okay, so very straightforward. To find equation of perpendicular bisector of AB, find gradient and find one point on that line. So over here, midpoint of AB is simply equals to, okay, I add the two x coordinate together, 0 plus 2 divided by 2, comma, negative 3 plus negative 1, the whole thing divided by 2. Okay, midpoint of AB is simply 1, comma, negative 2. Okay, next one, gradient of AB. Gradient of AB, this is simply equals to y2 minus y1. So over here, y2 minus y1, I have negative 1 minus negative 3 divided by 2 minus 0. Okay, so this is simply equals to 1. Therefore, the gradient of perpendicular bisector of AB, this gradient here is simply 1 divided by negative 1. It will be equals to negative 1. Therefore, from here, equation of perpendicular bisector of AB, the equation is simply, I know the point, it is simply y minus negative 2 over x minus 1 equals to negative 1. Okay, so therefore from here, y plus 2 is equal to negative x plus 1, y equals to negative x minus 1. So that is one way which we have found the equation of the perpendicular bisector of AB. Okay, so let me minimize this, then write the other method out as well. Okay, I put this one side over here. Okay, method 2. Something which may be slightly different from what you may have thought of. Method 2 over here. Okay, remember to find the equation of any perpendicular bisector, we need one point first. So over here, I let this point P, okay, I let this point P where the coordinates are x, comma y, be a point on the perpendicular bisector. Okay. Okay, so now I know that since this point lies on this perpendicular bisector, and this perpendicular bisector of AB, and let's say when I choose any point that lies along this whole line over here, the distance between the point P from A and B is always the same. No matter where my point P is, the distance AP to BP, it is always the same because point P lies on the perpendicular bisector of AB. Okay, so I hope you understand what's the meaning of a perpendicular bisector. So any of AB means that any point that lies on this line here is equidistant from A and B. So over here, this means that the distance AP is equal to the distance BP. Okay, so therefore, if I were to write it as an equation using my length formula, I know that point A, the coordinates is 0, negative 3. So over here is simply x minus 0 square plus y minus negative 3, which will give me, let me write out, minus negative 3, the whole thing square. This length formula here is equal to square root of, okay, and for BP, the formula is simply x minus 2 square plus y minus negative 1, the whole thing square. Okay. So from here, I square both sides, we get rid of the square root, I will get x square plus y square plus 6y plus 9 equals to x square minus 4x plus 4 plus y square plus 2y plus 1. Okay, so from here, I note that my x square and y square can cancel out. I will simply get, what am I left with is simply x 6y plus 9 equals to negative 4x plus 2y plus 5. Okay, so over here I will simply get 4y equals to negative 4x plus 4, y equals to negative x minus 1. And with that, I have found the equation of the perpendicular bisector as well, an equation that relates to the x and y coordinates of any point that lies on the line. Okay, so here are two different methods that we have used to find the equation of the perpendicular bisector. Method 1 is the most common one, which you have used very often and you should be very familiar with. Method 2 might be slightly unfamiliar to you. Okay, and that is for part 1 of this question. Okay, so the last part here, find the equation of the circle. So always remember, to find the equation of the circle, you need two things, center of circle and radius of the circle. So let's find the center of the circle first. I know that over here, okay, the center of circle lies on this line, okay, this line here, and the perpendicular bisector also cuts through the center of the circle. So let's write that the two equations down, part 2. Okay, y equals to negative x minus 1, and the other equation that cuts the center of the circle is y equals to negative 2x. Okay, both lines cuts center of circle. So therefore, to find the center of the circle, I just need to solve them simultaneously. So by simultaneous equations, I will get negative x minus 1 equals to negative 2x. Therefore, x equals to 1, and which tells us that y is equal to negative 2. Okay, so therefore over here this tells us that, therefore, center of circle, the coordinates is simply 1, negative 2. Then from here, to find radius of the circle, radius is simply equals to, using my length formula, I know the center of the circle now, I can just choose one point that lies on the circle. So let's say I choose, over here, I choose point A that lies on the circle, 0, negative 3. So to find radius of the circle is simply 0, point A, minus 1 square plus negative 2, 0, negative, point A is negative 3. Negative 3, then minus away negative 2, the whole thing square. Okay, the whole thing square. Okay. Therefore, your answer will be simply square root 2. So therefore, equation of the circle final answer to this question is simply x minus 1 square plus y plus 2 square, then the whole thing equals to root 2 square, which is equal to 2. Okay, and that's our final answer to question 2. Okay, so let's move on now to question 3. Question 3 here. Okay, I have this line y equals to mx, whereby m is a positive integer and does not intersect the circle. So for a line to not intersect the circle, it means that when I try to sub in this equation of the line into the equation of the circle, I should have no real roots. Meaning that when I sub this in eventually, I'll get a quadratic equation. This quadratic equation should have no real roots, which means that the discriminant should be less than 0. So how to work that out? Okay, so over here, I know that the two equations I have for part 1. Okay, the two equations I have for part 1 is simply y equals to mx, and secondly, x squared plus y squared minus 4x plus 3 equals to 0. Okay, so over here I'll sub equation of line into equation of circle. Okay, which means I'll get x squared plus mx, the whole thing square, minus 4mx plus 3 equals to 0. Okay, then from here, since we continue to simplify first, x squared plus m squared x squared minus 4mx plus 3 equals to 0, I'll get 1 plus m squared x squared minus 4mx plus 3 equals to 0. So therefore, from here, okay, since the line does not intersect not intersect the circle. Okay, this means that for this quadratic equation here, there are no solutions, and therefore the discriminant of this quadratic equation here should be less than 0. Okay, so that means that my b square minus 4ac, my b is negative 4m square minus 4ac, which is 1 plus m square times 3. This whole thing is less than 0. Okay, so over here, I just expand and simplify. I'll get 16m square minus 12 minus 12m square less than 0. I'll get 4m square minus 12 is less than 0. Simplify this, I'll get m square minus 3 less than 0. Okay, then I hope you still remember how to solve quadratic inequalities. We cannot shift this to the right and square root for inequalities. I have to factorize first. M plus 3 times m minus 3. No, sorry, not 3. It should be root 3. Okay, root 3 times m minus root 3, the whole thing less than 0. Okay. Then from here, once I factorize this, I sketch my quadratic curve. Smiley face curve. The intersections between the x-axis are negative root 3 and root 3. And less than 0 means I want the part of the curve that is below your x-axis, which is this part over here. Oops, let me use a yellow one. This part over here. Okay, therefore my final answer is simply, therefore m is between, oops, why is it red? Okay, therefore final answer, m is between negative root 3 and root 3. Okay, and if I look at the question again, since I know that m is a positive integer, therefore root 3 is 1.7 something, so therefore answer is that m is equal to 1, and that is your answer for part 1. Okay, then now let's look at part 2. Let me minimize this. Okay, shift this. Okay, part 1 done. Part 2 now. A line parallel to the line to y equals mx is a tangent to the circle. So let's look at this using m equals to 1. Okay, so using this value of m found in part 1, m equals to 1, the equation of circle is simply x square plus y square minus 4x plus 3 is equal to 0. Hey, this is the equation of the circle. Okay, so now in order to find this circle over here, I can rewrite this equation of the circle to find the center and radius of this circle. So over here, to make it easier, let's say I want to let this equation of the required line. So let's look at the question again. Okay, let me highlight some important parts. Find the possible equations of this line using the value of m found in part 1. So this line here is parallel to the line y equals mx. Okay, so that means that this line, okay, the line, okay, the gradient of line is equal to 1 because it is parallel to y equals to mx and m is equal to 1. So we know that this line over here, gradient is 1. But I don't know what is the other coordinate. So over here, I can simply let the equation of this line here be y equals to x plus, I don't know what's the y-intercept, so I call it k. K, whereby k is a constant. So very simply over here, what I want to do is that since this line is a tangent to the circle, so this is the equation of the circle, this is the equation of the line. For the line to be a tangent to the circle, it means that when I sub the equation of this line into the equation of the circle to find intersection points, there is only one or two equal solutions, or one real solution in this case, and the discriminant is equal to 0. So this means that when I sub this in, let's write out sub equation of line into circle. Okay, I will get x square plus x plus k the whole thing square minus 4x plus 3 equals to 0. Then I expand and simplify from here. Okay, x square plus 2kx plus k square minus 4k plus 3 equals to 0. Okay, so from here I simplify further. I will get 2x square x. Okay, so 2x square, this is a x, let me write it clearly, plus, what happened? Okay, this is a x square, wait okay, so 2x square, then plus 2k minus 4x plus k square plus 3 equals 0. Okay, and therefore this is my resulting quadratic equation. For line to be a tangent to the circle, be tangent to circle, I know that the discriminant of this case, in this question, d should be equals to 0. So therefore my b square minus 4ac, which is simply 2k minus 4 square minus 4 times 2 times k square plus 3, this should be equals to 0. So if we continue to expand and simplify, 4k square minus 16k plus 16 minus away 8k square minus 24, this whole thing is equal to 0. Okay, so I continue to simplify from here, I'll get, I continue to simplify from here, I should get negative 4k square minus 16k minus 8 equals 0. I divide the whole thing by negative 4, I'll get k square plus 4k plus 2 is equal to 0. Okay, so once I've done that, I can simply now solve for k using your quadratic equation. So let me minimize this so I have space. Okay, over here, okay, so from here, I get this quadratic equation. Just use a quadratic formula to find k. So therefore, k is equal to negative 4 plus minus square root b square minus 4ac, which is 4 square minus 4 times 1 times 2, the whole thing divided by 2 times 1. Okay, I will get negative 4 plus minus 16 minus 8, which is simply root 8. The whole thing divided by 2. Okay, root 8 is 2 root 2, so this is simply negative 2 plus minus root 2. Okay, so once I got this, I gotten my possible values of k from here. Okay, so therefore, to answer the question, therefore, possible equations of the line are, I have y equals to x, then minus 2 plus root 2, or y equals to x minus 2 minus root 2. And that is your final answer to question 3. Okay, this is a long question. Okay. Alright, so let's now move on to the next question, question 4. Okay, B4 here, a circle has this equation. Find the coordinates of the center and one of this circle here. Okay, I think this question is very straightforward. It's just by completing the square you can use your formula. So let me just, I will skip the first part of how do I obtain to the, by completing a square, I'll just write out the answer straight away. This is simply x minus 3 square plus y minus 1 square equals to 25. Okay, therefore, center of circle is simply 3, 1. Radius is simply equals to 5. Okay, and this is part 1 done. Okay, next part. Part 2. AB is a chord on the circle. Given that midpoint of AB is 2, 3, find the equation of the line AB. So over here, let's look at part 2. Let me write it here, part 2. Okay, so for this part over here, let's see if I can. Okay, maybe let me draw so that you can visualize if you are not very sure. For this part here, okay, let's draw this circle out. Okay, this circle here, center is 3, 1. Okay, so over here that means that the center is roughly about 1, 2, 3. Okay, okay, let me move this. Okay, so center of circle maybe it's somewhere about here. Okay, oops. 1. Okay, I call this the center of the circle. 1, 2, 3. Okay, radius is about 5 units. So if I were to draw the circle, it will be quite big lah. Something like this. Okay, not the most accurate drawing, but I hope you can get what I'm trying to show you. Okay, this is okay lah, something like this lah. Okay, you can visualize yourself what this circle is like. Okay, so center of circle, something like this. Okay, so over here I say that midpoint of AB, I don't know where is point AB. Let's say let me put it here. Okay, I don't know where is point AB, so let's say point AB is somewhere here and here. Okay, I don't know where is point AB, right? But I know that the midpoint, this midpoint here, this is 2, 3. Imagine this is A and B. Midpoint is 2, 3. Okay, find the equation of this line here. To find the equation of this line, I need 1 point and the gradient. I know that 2, 3, this point here lies on AB. I just need to find what's the gradient of AB. Okay, and if you notice over here, this is the center of the circle. AB is actually perpendicular to this line here, from this midpoint to the center of the circle. That is the perpendicular bisector of AB. So over here, what I can do is that I can first find gradient of line joining the points 2, 3 and the center of the circle 3, 1. The gradient here is equal to 1 minus 3 over 3 minus 2. Okay, the gradient of this line is simply equals to -2. Okay, therefore, I can straight away tell that since the gradient of this line is -2 and AB is perpendicular to this perpendicular bisector here, which cuts the center of the circle, therefore, gradient of line AB is simply -2 divided by, take a reciprocal and divide by -1, I will get half. Okay, therefore, final answer, equation of AB, the line AB is simply y minus away 3 over x minus away 2 equals to half. Therefore, y minus 3 equals to half x minus 1, half x minus 1, y equals to half x plus 2. Okay, and that is for part 2. Okay, let me minimize this. Okay, this is for part 2. Now let's look at part 3. CD is the diameter of the circle. So CD is probably a line like this, and they say that CD is parallel to AB. Okay, so this means that I know the equation of line AB now. Okay, for part 3. Okay, part 3, since line CD is parallel to the line AB, I can tell from here, therefore, gradient of line CD is equal to half, since it's parallel to line AB. Okay, and since CD cuts through the center of the circle here, Center of circle, I found it to be 3, 1. Okay, therefore equation of line CD. Okay, equation of CD is simply y minus away 1 over x minus away 3. X minus away 3 is equal to half. Okay, therefore, I can tell the equation of line CD is simply y minus 1 equals to half x minus 3 over 2. Y is equal to half x minus half. Okay, and this is for part 3, equation of line CD. Okay, then the last part 4, hence find the coordinates of C and D. So if I were to draw on this diagram here, CD probably is a line like this. Let me draw it over here. Okay, CD is probably a line like, okay, very hard to draw this line cutting through center of circle. Something like this lah, okay? Then I know that this is C, this is D. Okay, point CD lies on the circle and also lies on the line. So for part 4 is simply part 4 here, I know equation of line CD is equal to y equals to half x minus half. Equation of the circle is x minus 3, or actually it's given by the question over here. Let me write out clearly. X squared plus y squared minus 6x minus 2y minus 15 equals to 0. So to find the coordinates of C and D, simply need to solve these two equations simultaneously to find the coordinates of C and D. So I won't work through the solutions for this. Just need to solve simultaneously to find coordinates of C and D respectively. Okay, and if you manage to solve this correctly, let me write out the answer so you can check. For coordinate of C, it should be 3 plus 2 root 5, 1 plus root 5. Okay, and D, based on the textbook, it should be 3 minus 2 root 5 and 1 minus root 5. Okay, and this is for part 4. Alright, so this is the solution to question 4. Okay, so now let's look at the last question over here. Okay, last question, B5. Okay, a circle and line have the equation respectively. Find the range of values of k for which the two graphs intersect at 2 points, 1 point, or no point of intersection. So over here, this is actually a discriminant question. What we need to do first is to rearrange to sub the equation of a line into the equation of the curve. Then I can get a resulting quadratic equation. So let's do the first part. Okay, over here, equation of the line. I write the circle first. Circle is x squared plus y squared minus 4x minus 2y plus 1 equals to 0. Line. Okay, this is simply kx minus y equals to k plus 1. So I make y the subject. Y equals to kx minus k minus 1. Okay, so therefore, to find the intersection points between the circle and the line, I just need to sub equation of line into equation of circle. Okay, so what I need to do now is x squared plus kx minus k minus 1 square minus 4x minus 2 times kx minus k minus 1 plus 1. This whole thing equals to 0. What I need to do now is simply I will expand and simplify everything such that I will get a term which is something x squared. This is your ax squared plus something x plus another constant. Okay, so expand and simplify such that you can get this resulting quadratic equation here, whereby you combine all the x squared term, and the constant terms. Then for part 1, very simply, I won't go through the full detailed solution because it's rather straightforward. For part 1, for the circle and line to have two distinct points of intersection, it means that the discriminant is strictly greater than 0. So you sub in your b squared minus 4ac this is more than 0, then you solve this as a quadratic inequality to get the answers for this question. Okay, and part 2, for there to be one point of intersection, discriminant should be equal to 0. So therefore b squared minus 4ac equals to 0. Then you sub in from here to solve for the question. And the last part, for the circle and line to have no points of intersection, I will sub the discriminant should be strictly less than 0. So you sub in your b squared minus 4ac less than 0, and you solve for this inequality. Okay, so this is a rather long steps, so I will not go through in detail, but these are the main steps to take note of solving question 5. Alright? Okay, so this is the end of this revision set B for circles.